Everyone, you are highly welcome. In today's tutorial, we are going to solve this problem on the board. So this is called radical equation. Okay, so if you want to solve this, whenever you want to solve radical equation, you need to always check the domain. So from here, I would like to check the domain of this function. I have this function under this radical sign, that is 5z plus 4 must be greater than or equal to 0. So now let's see what we have, or the possible values of z we can have. We have 5z, okay, plus 4 greater than or equals to 0. So we have 5z greater than or equals to minus 4. So from there we have 5z. So we divide both sides by 5. Okay, so you see that this cancel this. We are going to be left with z, then must be greater than or equals to minus 4 over 5, and that will be minus 0.8. Then also the second one, our second function is z plus 2, that is this one here, okay, must also be greater than 0, because these square roots cannot give negative value. So that is why z plus 2 must be greater than 0. So from here we have what? We have z greater than or equals to minus 2 if this should be transposed to the right hand side. Okay, so now when you look at these two now, so you see that one has now countered another, because minus 0.8 here has countered the minus 2, because minus 0.8 is greater than minus 2. So therefore, the last one, the domain, the set of domain we are going to be considering now is z greater than or equals to minus 8. So we are going to discard this, then we look at this. So moving on, so we can now solve our problem. Let's solve it from the beginning. So let's bring down, we have the square root of what? Of 5z plus 4 equals z plus 2. So from there, the next thing we're going to do is to square the both sides of the equation. If I square it like this, so you can see that the square, we cancel the square root, we're going to have 5z. You're going to have 5z, then plus 4 will be equals to z plus what? Z squared. When you square that, because this is perfect square, and you remember when you have perfect square, you have a plus b all squared. So this is going to be a squared plus 2ab then plus b squared. So that's the same thing we are going to use here. Z squared plus 2 times 2z, that would be 2 times 2z, 2 times 2z, okay, then plus 2 raised to power 2, that will give us 4. So we're going to have 5z plus 4 will be equals to z squared then plus 4z, okay, then plus 4. Now looking at the both sides of the equation, so you can see that this and this are the same thing, so we can cancel them. This can be cancelled. Then we're going to have what? We're going to have z squared plus 4z then minus 5z, then everything equals to 0. All right, so we have z squared then minus z, because 4z minus 5z will give us minus z. So that's what we have, then equals 0. So now from here we factorize s, because we can have z times z give us z squared then minus z, then everything equals to 0. So now we can see that z is common from this side here. From here, z is common from the two terms. So we're going to what? We're going to factor out 1. We have z minus what? 1, then equal to 0. So now from there, z is equals to 0, or z minus 1 equals 0, then z equals 0, or z equals 1. Now looking at this, now we want to know whether the result we have, the value of z and the value of z 0 and 1, if they fall in the what? In the domain. Then if you look at the domain we have z must be greater than, our domain is z must be greater than or equals to minus 8. So now, since let's say the domain is z then equals to minus 0.8, so which means that our z equals 0 is greater than minus 0.8, which means we are going to what? We are going to pick it is valid. Another one, z2, our 1, you can see that is also greater than minus 0.8, so which means we are going to pick this one too, which means the two solutions are valid solutions. And that's the end of the class. If you find the class very interesting, so kindly share to your friends so they can learn from this. Thank you so much for watching.